Welcome to this series of videos where we are discussing about outliers. So in our previous video, we saw the conceptual understanding of what is outlier. In this video, we are going to understand the first statistical method, which is called the Z-score method of understanding whether my given set of data have outliers or not. Let's get into the video. The first thing that we need to understand is before we do any statistical calculation or statistical analysis is whether my given data have outliers or not. We saw what is the impact of outlier and what could be the reasons to get an outlier in the data. Now we will see how to identify whether my data have outliers or not using a technique or method called z-score or z-score method. So people who have seen my previous video on ZMR chart, there I have clearly explained what is called a z-score or a z-score. For those who have not seen that or those who do not know what is a z-score, let me quickly explain what is a z-score. In a given set of data, let's say this is a histogram. So in this histogram, 175 is a given data point somewhere in the curve. Now I want to know the z-score for this particular data point. So what is z-score? Z-score simply is nothing but how far is your individual data point, in this case 175, away from your average. So if you just keep it at this point, you will simply say 175 minus 200 minus 45 units. So 175 is minus 45 units away from its average called 220. So that's simple. But the question does not end there. How far is your individual data point away from your average in terms of its standard deviation? So what do we mean by in terms of its standard deviation? I don't want to know the distance between individual data point from its average in absolute value. Instead, I want you to tell me the distance of the data point from its average in terms of standard deviation. That means the unit should be not absolute value, but instead the unit should be standard deviation. Then what we do? We calculate the distance between individual data point from its average, and then if you divide it with standard deviation, then you will come to know 175 is minus 1.8 times of standard deviation away from its average, right? So this 175 is a smaller number compared to average. If the given value is a bigger number compared to average, for example, if it is 250, then what you do? You will say 250 minus 220, which is 30. 30 divided by 25, whatever is that value, you will say 250 is 1.05 or 1.01 units away from its average. So this is what we call it as z-score. Z-score, simply the formula is given value minus the average divided by standard deviation of the data point. So that will give you the z-score for a given data point. So what we will do here, we have a 30 units or 30 data point. To start with, first let's calculate the average. So the average is so the average is 5.93. Then let's calculate the standard deviation. Let's calculate the standard deviation. So we have average of 5.93 and we have standard deviation of 0.90 for the given set of data. So how do I calculate z-score? The z-score will be given value minus its average, right? And to keep this average constant for all the values, I'm going to add a dollar value before the alphabet and before the number. By doing this, what will happen? I can simply copy paste this formula. So I freeze the cell by adding a dollar, and now I divide it with standard deviation. Again, for standard deviation, I freeze the cell so that I can simply copy paste the formula. So let me add the dollar value. So now what does it mean? For a given set of data where its average is 5.93 and standard deviation is 0.90, 4.99 is minus 1.05 standard deviations less than its average. So that's why the z-score is minus 1.05. Now what I can do, I can copy paste this particular formula for all the cells. Then I will get the corresponding z-score or z-score, right? Okay, so now we have calculated the z-score. So that part of the calculation is over. Now we will come to the standard normal distribution curve. So many of you again would have seen the standard normal distribution curve being discussed in my videos before. But for those who are listening to the first time, a standard normal distribution curve is one where your average will be at 0 and average plus one standard deviations on both sides. You will approximately have 68 percentage or 68.3 percentage of data, and average plus two standard deviation on both sides you will have 95.4 percentage of data, and average plus three standard deviations you will have 99.7 percentage of data. So what does it mean? This method of identifying whether the data have outliers or not can be used only for a distribution which is normally distributed, the data which is normally distributed. So that's one of the important requirements, right? So if my data is not normally distributed, then how do I understand whether it has outlier or not? We will explain that in our following discussions, right? In our upcoming discussions, I will explain that part also. As of now, this data is normally distributed, and now I wanted to know whether my data have outliers or not. So we have calculated the z-score. Once we calculated the z-score, then there are two different formulas or two different rules that we have. Rule number one: if your data is or your data point is falling two standard deviations from your average, that means if your data point is more than two standard deviation away, then what will happen? Because 95.4 percentage of data is expected to fall within two standard deviation. So if a data point falls beyond two standard deviation plus or minus, then we can consider that data as an outlier, is rule number one. Rule number two is if a data falls beyond three standard deviation, then we can consider this as it as an outlier, is the second rule. Generally these are rules being followed, but I have a difference of opinion. I don't agree, or I don't follow this method, but as part of this explanation I'm explaining all the methods available. So we will first calculate this, then I will also tell my opinion of what I think as an outlier. So first let's do the calculation, right? I say is equal to, so let's use a formula which is if yes, right? So the logical test, we can do multiple tests by using if s. So I say this value is greater than 2, then call it as an outlier, comma. The next condition is if b2 is less than -2, then also call it as an outlier, right? And now I can close the bracket and I can hit enter. So what will happen? Yes, this data is not greater than 2 and not less than -2, hence it has replied me a not applicable formula, right? So what I need to do is I have to slightly make a modification, and that modification is if not applicable, right, comma, you can say not an outlier. Right, now if I close this, right, so what will happen? I can copy this formula and I can paste it here, and here if you see this data point is 2.3, that means 8 is 2.3 times of standard deviation away from your average on the positive side, and similarly 3 is minus 3.25, that means 3.25 units of standard deviation less than your average, hence that is also called as an outlier, right? Okay, so what we can do is the second rule is extreme z-score value beyond 3 standard deviation. So what we can do is we can copy this formula, we can paste it here and make this 2 into 3, sorry, 3, and make this -2 into -3, and then hit enter. Now if you copy and paste this, you will find 8, which is plus 2.3 units of standard deviation away from average, or its corresponding z-score is 2.3, and it is not called as an outlier, but 3 which is minus 3.25 units away from its average, hence it is called as an outlier. So friends, the z-score method is a method where your absolute value get converted into the corresponding z-score value, and by that z-score we apply a condition whether the data point is more than 2 standard deviations, or the z score is bigger than 2 or less than -2, then it will be called as an outlier. Or if the z score value is greater than 3 or less than -3, then also it can be called as an outlier. So this is called 2 standard deviation rule or 3 standard deviation rule. Friends, I hope this video was useful for you to understand how to determine whether your given set of data have outlier or not, depending on the z-score calculation method. And after calculating z-score, whether you want to apply as 2 standard deviation or 3 standard deviation rule. But as I was explaining before, I'm not a big fan of this method. You will understand why I am not a big fan of this method as I'm going to explain the other techniques or other methods by which the z-score can be calculated, right? So please subscribe to our channel and keep watching our channel, where we will be discussing about the other methods to calculate the outlier. Thanks for your time. See you in the next video.